Welcome to in this video. Today, we will discuss about the physical layer. So, let's start the video. The physical layer is the first layer in the OC, Open Systems Interconnection, model of network communication. Its primary role is to transmit raw bit streams over a physical medium. It deals with the hardware aspects of networking, such as cables, switches, and the electrical signals that travel over them. Here's a detailed look at the physical layer, purpose and functions, signal transmission, encoding and decoding. The physical layer translates data into signals that can be transmitted over a physical medium. It encodes data into electrical, optical, or radio signals and decodes incoming signals back into data. Data rate, transmission speed. It determines the rate at which data is transmitted, measured in bits per second, bps. This rate depends on the capabilities of the medium and the technology used. Physical medium, cabling. The physical layer specifies the type of cables used, such as twisted pair cables, for example, Cat5e, Cat6, coaxial cables, or fiber optics. Connectors. It defines the connectors used to interface with the cables, such as RJ45 for Ethernet or LC/SC/ST for fiber optics. Transmission techniques. Analog versus digital. It can use analog signals, continuous waves, or digital signals, discrete pulses. Baseband versus broadband. Baseband transmission uses a single channel for digital signals, while broadband allows multiple channels over a single medium, often using analog signals. Examples of physical layer technologies. Ethernet. Wired Ethernet uses twisted pair cables, for example, Cat5e, Cat6, to connect devices. The physical layer specifies the electrical signals and encoding methods used in Ethernet standards like 10 base T, 10 megabits per second, 100 base TX, 100 megabits per second, and 1000 base T, 1 gigabit per second. Fiber optic networks. Optical fiber uses light signals transmitted through glass or plastic fibers. Fiber optic cables offer high bandwidth and are used for long-distance and high-speed communication. Wireless networks. Wi-Fi utilizes radio waves to transmit data between devices and access points. The physical layer in Wi-Fi, for example, 802.11a/b/g/n/ac/ax, handles the modulation and signal transmission over the air. DSL, digital subscriber line, copper telephone lines, uses existing telephone lines to provide high-speed internet. The physical layer in DSL technologies involves modulating digital signals over the copper pairs. Key concepts: modulation, analog modulation, techniques like AM, amplitude modulation, and FM, frequency modulation, are used to encode data onto analog signals. Digital modulation, techniques such as QAM, quadrature amplitude modulation, and PSK, phase shift keying, are used for encoding data in digital signals. Bandwidth, frequency range, refers to the range of frequencies that the medium can handle. Higher bandwidth allows for faster data transmission. Signal integrity, attenuation, the loss of signal strength over distance. Interference, external signals that can distort or degrade the quality of the transmitted signal. Noise, unwanted signals that can interfere with data transmission. Error detection, while the physical layer itself doesn't handle error correction, it must ensure that signals are transmitted reliably enough so that higher layers can detect and correct errors. Standards and protocols. The physical layer is defined by various standards and protocols that specify how signals are transmitted and received. Examples include IEEE 802.3 for Ethernet standards, IEEE.703 for digital telecommunication interfaces, IEEE 802.11 for wireless networking standards. Conclusion: The physical layer is crucial because it underpins all higher layers of network communication by ensuring that data is transmitted across physical mediums. It encompasses everything from the physical characteristics of cables and connectors to the electrical or optical signals used for data transmission. Understanding the physical layer helps in diagnosing network issues and optimizing the performance of network infrastructure.